In this one, I'm going to show you what are special files on Linux. Well, I call them special, but they're not special. It's just files that you encounter not so often. So here I have a few examples. So for example, dev0, which is just a file that you can read and it outputs a bunch of zeros, which is actually, well, it's not an actual file, like as a file on disk. It's a character file, or like there is my drive, which is an NVMe drive, and then we can see that some of it is a character device and some of it are block devices, and block devices are for just actual physical storage. And then you have, for example, all the TTY devices, which are all character devices. And we can see that in each of those, there is something that there isn't for regular file. There is two numbers that are associated with all of them. And you can see that for TTY, most of them are 4, but then the other number is something different. For NVMe also, there seems to be some kind of categories. And so those are created with the mknod syscall, which is an old syscall which has a lot of legacy, but nowadays I think it's mainly used only for creating these kinds of files. So let me demonstrate how it works. So you can call in C the mknode with a path. So I will, for example, say my 0, which will be my 0 device, like so. The next flag is just the mode, so I will just say very normal permissions. And then a bit of a strange thing, you have to OR this with the file type. So the file type is this, so C or B, so a character device, a block device, or a regular file, and so on and so on. So this is SEF, and this will be a character device for 0. And then there is the dev, which for some of them can be just 0 if it needs to be ignored, but in this case it actually corresponds to something, so we need to use make dev, and so there is a major number and the minor number. The major number is what is the first one here, and the minor number is the second one. So the major number says which driver inside of the kernel it corresponds to. So I'm guessing here there is one driver that is for block, like NVMe block files, and there is one driver which is for pseudo files, I guess you could call them. I'm guessing this is dev0, dev-random, dev-null, and so on and so on. And so for dev0, the major number is 1, the minor number is 5, and so the minor number is like one file, like each file that is handled by this driver gets a minor number. So in this case, it's 1.5, and so if I compile this, and I do need to be root for that one, so I will run it with doas, which is just sudo for hipsters, and okay, now I type my password, and we will see that I have a my0 device. And so I can, for example, read it like so. I read 10 characters from it, I xdump it, and you see it works exactly the same as the regular dev 0. See, exactly the same. Let's do another one. Let's do urandom. So again, it's handled by this one major number, and the minor number in that case is happens to be 9. So let's remove the other one. Let's rerun it. Now I have a my urandom device here, which I can which works exactly the same as urandom. So this is like the official one, and my urandom, and it works exactly the same. It's also random bytes. A cool thing is that I think one of the coolest thing was I can just created a device for my disk. So what I did before was dev nvme something, and so we can see this. Oh, maybe I should. This device, this file here is my actual the disk where my whole file system is mounted. So I can just literally copy those numbers. So I can say 59, 259, this is the major number for NVMe disks, and then I can say 3 to get that one. And this will be, this time, not a character device, this will be a block device, like so. And so if I do this now, we should see that I have my disk here. And so what I can do is I can create a random directory, and I can mount my disk to this mnt directory. So I have to be root to mount. Okay, yeah, of course the ls doesn't work anymore, but I can cd into mnt, and all of a sudden, my whole computer, my whole file system, root file system, is there. So I can do home, Charles, git vids, and mknod, and we end up back at the same thing. I wonder if that... Okay, the mount isn't recursive. Okay. So, but anyway, you can see that it's quite funny. I can just have my disk, disk device in this random directory. I think ls doesn't work for some reason because I'm doing some recursive stuff. Let's do umount of that. Up, so I can ls again. And so what I wanted to show next, this is mainly it for the, I don't know, these major and minor numbers. I just wanted to show you that there is multiple drivers, and each one of those drivers can have any number of like quote-unquote files associated with them, and this is how you can access them. Of course, for some of them you have to be root, or all of them. I think there is a special capability for this. Yeah, there is just this file in the Linux kernel documentation where you can see, oh, well, for example, the major number 1 was for memory devices, and so I showed you, I think, random and 0, but you can see that null is also part of this, or yeah, apparently you can access your own memory with devices like this. There is RAM devices, there is the sudo tty, there is one for floppy disk. I always thought this was for file descriptor, but apparently this is floppy disks. Yeah, there is tty devices, you know, there is all kinds of stuff. I'm sure if we look for this number, we will see block extended major used to dynamically additional partition major. Okay, this is not what I expected, but I don't know. Not sure how it works, but there is a huge list of major and minor numbers, so it can be very useful. So this was the main, let's say, meat of the video, but I wanted to show a few extra stuff. So the mknod file system is very generic, so here I've only used it to create character and block devices that are already set by the kernel, but you can also create a FIFO file from this. And so what FIFO file are, it's just, well, a better name for them is named pipes. So if I do something like hello pipe into cat, so this pipe here can be made as a file. So it will be exactly the same thing as a pipe, except that it will have, an enode on the file system representing it. So the way you can do this is my FIFO, like so. The file type is FIFO. They reuse the F because they're very clever. And like so, and I can just do gcc. I don't think you need to be root for that one. And so now you can see I have my FIFO with a little pipe next to it, and this is just a file. And so if I echo into this my FIFO file, like so, you see that it's blocking because it's just like a pipe, and then I can cat my FIFO, and yeah, it's the exact same behavior as a regular pipe, except that it's named, which is quite useful for inter-process communication stuff, like if you have two processes that are started and stopped from time to time, and yeah, they need like a, let's say, a determined point on the file system where they can communicate. This is quite handy. But of course, you should use. There is a library function for this in the standard C library, which is called mkFIFO, which I'm guessing is more portable and just a bit less clunky than the mknode one, but it does the same. And yeah, the last thing I wanted to show is that this can also just create regular files for some reason. Like there you go. You have now a regular file. My yeah. So yeah, I think it started out as a very generic syscall. So they had everything you can create. Like you could create Unix sockets and everything in there. Like ifsoc, and now there is more specialized syscalls like open or mkdir or something like that. But anyway, I think for to create like special device files, this is still in use. So anyway, I hope this video like unveiled a bit the mystery between those special device files and yeah, FIFO, well, no, named pipes files. So yeah, let me know if you liked it, and I'll see you in the next one.